Perspective Class 13 Video 1. In this video we're going to talk about crossing glyphs. So before I get on to the definition of exactly what a crossing glyph is, I just want to give you an example which highlights the need for crossing glyphs, highlights their usefulness. So let's imagine that we are going to project a square and a circle. Parallel projection or central projection, it doesn't matter. So there's a square and a circle living in three-dimensional space, and we project them onto a two-dimensional plane. And the resulting image is going to look something like this, and then that's my attempt at a circle. Okay, so there's overlaps, but the issue is, based solely on this resulting image, you can't tell which one is in front. Like, is the square in front of the circle, or is the circle in front of the square? You just can't tell, because they look perfectly flat. Like, this is the resulting image of a parallel or central projection. So crossing glyphs help us convey more information in the projection. The crossing glyph will help us convey which object, which shape is in front of the other shape. So let's write this as a definition. Crossing glyphs are a type of overlap cue. That is, they are a way of signifying that one line segment is in front of another line segment. Okay, and the actual definition of the crossing glyphs, like the practical definition, is incredibly simple. It's just, you have two line segments which cross one another, and you want to convey to the reader that one of these is in front of the other. So you've got two choices. If you want to make the one going uphill in front, you draw that first, and then you draw the other one with a slight gap. And if you want to make the one going downhill in front, you draw that first, and then you draw the uphill one with a slight gap. Okay? So what's going on here is, in this case, the green one is in front, and in this case, this green one is in front. Okay, so if we go back to our square and circle picture, like, you can easily convey that the square is in front of the circle just by drawing it ever so slightly differently, like this. Okay, it's not the best picture, but it conveys that the square is in front of the circle. And if you wanted to put the circle in front of the square, then you should probably draw the circle first, and then you draw the square, like that. Okay, so this is crossing glyphs. It's just a way of conveying to the reader that something is in front of something else. So it's like, you have your central projection, you have your parallel projection image, and then you augment it ever so slightly. So let's see another example of this. How about we look at this cube right here? So this is perhaps a parallel projection of a cube, okay? But the trouble is, it's sort of ambiguous. You don't know what the front face of the cube is. Like, depending on how you look at it, maybe this is the front. Like, if you stare at it from one particular angle, you could convince yourself that this is the front of the cube. But if you stare at it from a different angle, or if you blink and look away then look back, maybe you'll convince yourself that this is the front of the cube. Okay? And you can't tell just based on this picture what is the front. So that's why we have to use overlap cues. For example, if I wanted to make the pink bit the front, if I wanted to make this the front of the cube on this example down here, what I would do is I would add the overlap cues like that. And now it's clear that this is the front. Okay. If I wanted to make this green face the front on the second cube, then I would probably add the overlap cube like this and like that. And now this green bit is the front of the cube. And I've drawn 2 extra cubes here because there's sort of 2 extra possibilities. You know, for every overlap you have 2 possibilities. You can either have it like this or you can have it like that. And since there's 2 overlaps, that means there's 4 possible combinations. So I've done the first 2 combinations, and if I do the last 2 combinations, we get something which is a bit strange. So if I draw something like this and like this, and like this and like this, well, now these 2 cubes, they sort of look impossible. Like they don't really seem like they fit into the real world. Okay, because sometimes you might think this looks like it's the front face, but then it goes behind here. And this looks like it's the front face, but then it goes behind here. So these are sort of like impossible cubes. Okay. So this is crossing glyphs, and they come up a lot. They come up in mathematics and in art. They're a really convenient way of conveying a lot of information very simply. One place they come up in mathematics extensively is in the study of knot theory. So knot theory, unsurprisingly, is the study of knots. So mathematicians spend a lot of time studying knots, and this is how they draw them. You draw them with these overlap cubes. Okay, so this right here, what I've included is a picture of like the first 15 knots. So there's infinitely many knots in the world, and this is like the first 15, including the unknot, which you might object to being a knot, but mathematicians consider it a knot nonetheless. Okay, so this is just another example of where overlap cubes are very useful. That's the end of this video.